All right, thank you very much. Hello, everyone. Thank you for joining us for the Amazon Glacier webinar today. My name is Henry Zhang, Product Manager of Amazon Glacier, and I also have Mr. Colin Lazier here. He's our Senior Manager of Amazon Glacier. So we're very excited about today's session. We want to share with you some of the benefits of using Amazon Glacier to build powerful archival applications. We also want to highlight some of the best practices when using the service, so you can get the most out of it and be armed when you work on your next application. So we'll go over the following topics today. For those of you who may be new to Amazon Glacier, we'll do a quick overview of the service. We'll cover some of the key benefits and some of the key use cases. And then we'll drill into the best practices and share with you on how to implement your applications. So just excuse me here. All right, sorry for the technical difficulty. We had a little latency in pushing out the slides, so I think we're all caught up right now. So we'll drill into the overview of Amazon Glacier. Yeah. So Amazon Glacier is a low-cost storage service built for data archival. So the key thing to highlight here is it's a low-cost service, it's a storage service, and it's also specifically designed for data archival. Some of the benefits you get from Amazon Glacier is you start at 1 cent per gigabyte per month, and you only have to pay for what you use. Contrary to some of the expensive on-premises archival solutions, you will not have to purchase expensive physical storage infrastructure, hire the staff and the floor space to maintain them over time. We believe this is a huge benefit to customers who are thinking about building archival applications but do not know where to start. In addition, Amazon Glacier offers highly durable storage over many geographic regions. As of now, Amazon Glacier is live in 6 AWS regions. If you haven't noticed, yesterday we just launched Amazon Glacier in Sydney, and we're getting lots of interest in the region. Amazon Glacier also stores your data in extremely secure manner. We'll go through some of the details later, but you can bet on Amazon Glacier taking advantage of all the AWS secure infrastructure in the data centers. In addition, you can use Amazon Glacier with many of the existing AWS services, such as EC2, which is the Elastic Compute Cloud. You can archive data in Glacier and then pull it out into your EC2 instances and do data analysis or aggregation when necessary. So as we mentioned, Amazon Glacier is specifically designed for archival solutions. So what is archival data? A good example I often reference is your kid's pictures. When the kid is born, the first day, the second day, every day you take probably dozens or hundreds of pictures, right? And then over the course of the year, of many years, you get a lot of pictures for the kids. And by the time the kids get married, you probably want to go back and go through all these pictures, select a handful, and then put together some slides for the wedding. So throughout this process, you've already done an archival, build an archival application. Notice that the pictures you take for the kids on the first day or the first year, you don't look at them frequently. But there is one time in his life that you will go back. So this signals the importance of archiving the data. The data is important to be retained for future references, even though you don't access it frequently. Same analogy applies to your tax records. You usually keep them around for many, many years. So in Amazon Glacier, we see customers who plan to archive their data for months, years, or decades. It is truly designed for long-term storage and archival. You will see such nature reflected in our pricing model as well. And then for businesses, there are very strict regulatory reasons to retain data over over long periods of time. Typically, a business will get a subpoena for an investigation which requires retrieving the data of one of their customers from many years ago. So typically, they have to retain the data for many years, and then they can do very well by archiving data in Glacier. So as we mentioned, Glacier is a low-cost archival storage service in AWS. When we design a service, we specifically optimize for low cost, with the trade-off that getting your data back can take longer. In Amazon Glacier, you typically can get data back over 3 to 5 hours. It's also it's an asynchronous process. We'll walk through that in a few slides from now. So here's a quick picture for you to reference. There are 6 benefits that you want to leverage when you build applications on Amazon Glacier. The first one is obviously low cost. We typically advise customers to think through a TCO model. What would it cost you over 3 years, 5 years by doing an on-premise archival solution, or by hiring some vendor that does an off-site archival solution for you? Then you can compare the requirements, such as the amount of data that needs to be stored, as well as how frequently and how much data you will retrieve over this period of time, and map the cost to Glacier. Then you can have a very good TCO model of 3 to 5 years, and then you can pick one. And typically we see Glacier wins out. Especially it's better for long-term archival, because your marginal cost of your storage goes down over time. As I mentioned, Glacier is also highly secure because it leverages AWS's security platform. AWS offers security audits from third parties, and we do that every 6 months. So you can count on Amazon Glacier being extremely secure for your highly sensitive data, such as financial information and health information. Glacier is also highly durable. We do that by storing the data over multiple facilities and on multiple devices. Glacier is designed with 11 nines of durability. So what does that mean? That means if you have 10,000 files stored in Glacier, the chance of losing one of them happens in 10 million years. That is hard to think about, actually, but that is how good our durability is, 11 nines. Compared to your on-premises archival solution, which is tape-based or single or multiple hard drive-based, our durability beats all of them. Amazon Glacier is also very simple to use. There's no upfront cost. You can just set up a Amazon Glacier Vault, as I will cover in the next few slides, and start uploading data. It's also very flexible because you only pay for what you use. And the last benefit I want to highlight is you can use Amazon Glacier with existing AWS services, such as EC2. You can also build index systems on Amazon Glacier using services like DynamoDB or RDS. So what types of data do our customers store on Glacier right now? We see a lot of enterprises archive their business records, their database backups, their unstructured content on Amazon Glacier. And a lot of them do that for business compliance reasons. Typically, they run into problems with storage costs because lots of data needs to be stored over a long time, and it's required by law to store them. Now with Glacier, they can cut down the cost and still meet the compliance requirements. In addition to that, we also see media companies archiving their crown jewels in Amazon Glacier. They leverage the system's durability, security, as well as the fact that storing data in Glacier makes it easier to access the content. For example, we have customers who typically archive their data in salt mines for their raw footage. When they convert this data into to Glacier, it only takes 4 hours to retrieve the data if they want to do a playback or issue a director's cut for a popular movie from decades ago. Compared to their salt mine solution, which takes multiple days to retrieve the data and logistics to ship the tape and restore it, Glacier is more accessible. Last but not least, we also see a lot of scientific data being archived in Glacier. We have multiple genome companies who store research information and personal genome in Amazon Glacier. Again, they leverage the fact that Glacier is low cost because genome data is explosive. It increases tremendously by the day as the research goes on. And also the fact that the data is securely stored and highly durable. So now let's go over some of the key concepts for Glacier. So on the left, you can see Amazon Glacier. On the right is your typical archive application. And it's really simple because you just do puts and gets to and from Amazon Glacier. You send data up to Amazon Glacier using HTTP, HTTPS, using our REST APIs. And you can also use our SDKs to simplify the process. In addition, you can use Amazon import service if you want to import a single disk image into Glacier. This helps if you have low network bandwidth and you want to do a large import into Glacier. We also support Amazon identity access management on Amazon Glacier. This can be done at the vault level. So you can set permissions and identify users that can upload data to Amazon Glacier and the users that can delete data from Amazon Glacier. A lot of customers ask us, hey, is Amazon Glacier a worm system? Because they come from a world where worm is required. Worm means read only, write once and read many times. So this is typical in compliance records archival where the data cannot be tampered. So a simple solution to implement worm on Amazon Glacier is to set up your IAM policy where you have the data uploaders do not have the permissions to delete any of the archive. On the right is your archive application. As I mentioned, Glacier is designed for cold storage, and we currently do not offer a hot index. So we see customers implement their own index on-prem, or they use RDS or DynamoDB. Archives and vaults are the two key concepts of Glacier. If any of you are S3 customers, you can think of them as very similar to objects in S3 as well as buckets in S3. An archive is just a durably stored block of information. It can be a single file, it can be a picture, it can be a collection of log files from your web service that you have zipped together. It can also be compressed file or encrypted files. Anything goes. It's just a logical container of bytes. From Amazon Glacier's perspective, you can store any amount of archives in a vault, and then the single archive can go from 1 byte all the way up to 40 terabytes. Vault is essentially a collection of archives. We implemented Vault so that you can have some separation across many of the archives that you have. At the Vault level, you can set permissions and access rules using the IAM policies so that some of the users can upload data, but they cannot tamper the data, such as deleting it. And then you can also set up specific rules for Vault so that certain customers can read the data. So here's a quick workflow of uploading data to Amazon Glacier. Step number 1 is create a vault. It's very simple. You can do that in our console. You can also do that programmatically. Once the vault is set up, you can use our SDK or our APIs to upload data into the vault. And once the data is uploaded, you can start retrieving the data whenever it is necessary. The retrieval process typically takes 2 to 5 hours, and it's asynchronous. You initiate a retrieval job, you get a confirmation, and then you'll be able to track the job status. And then once the retrieval is done, you can download the job output. So a quick note here is the download and retrieval process are two independent processes. Retrieval is the process where Glacier makes your archive data ready for download. You can also be notified when this data is available for download using our SNS service at the vault level. Some additional considerations when you send and retrieve data to and from Amazon. You can always use the Glacier REST APIs and SDKs, but if you plan to upload large amounts of data into Glacier, we would recommend you to consider using Direct Connect, which is one of the services Amazon offers in multiple regions. You can establish 1 gigabit dedicated connection or 10 gigabit dedicated connections to upload large amounts of data to Glacier. We also support S3 customers by allowing them to use the lifecycle rules to automatically archive objects into Glacier. S3 customers in all the regions that Amazon Glacier is available, S3 customers can simply use lifecycle policies and specify prefixes as well as certain rules to archive to Glacier. For example, you can say all the objects that are created X number of days or older will be archived to Glacier. Or you can say all the objects in this bucket with this prefix will go to Glacier by the end of the month or by the end of the year. Using these rules, you can map your business requirements to the archival policies. The key thing here to note for S3 customers is when you archive data to Amazon Glacier, it's a move. It's not just a copy. As I mentioned earlier, Amazon Glacier is designed for cold storage, an archival system. In order to lower cost, we do not provide a hot index system. However, in the case that you lose your local index, we do provide a vault inventory. The vault inventory is basically a collection of all the archives in a vault, and we typically update that over 24 hours. It's a disaster recovery method in case you lose your local index. As I mentioned earlier as well, at the vault level, you can set up simple notification services, such as when an archive has been retrieved, so you can start the download process. You can also set up notifications for when certain archives are uploaded so that you can take reactions. So this picture shows all the key Glacier concepts put together. On the left, we create a vault. When you create a vault, you can attach IAM policies to it, set up users. You can also set up notification services at the vault level. Then you can upload archives into your vault, and then based on your business requirements, you can retrieve archives using a 3-step process. Now let's dig into some of the best practices with Amazon Glacier. The first thing we want to cover is how do I deal with my data? A lot of customers tell us they have large number of small objects. Typically, those will be small images, things like lots of tweets they want to archive, and also small files such as log files. Cost is the first thing we want to optimize here when you decide how to upload large number of small files. At the moment, every request that uploads an archive is charged at Amazon Glacier. For example, in our North America region, it costs 5 cents to upload 1,000 archives. So if you have millions and millions of small files, the request cost can go up. In that case, we would recommend aggregating your small files into larger sizes. This does two things for you. On one hand, it lowers the request cost, as I just mentioned. On the other hand, every object that you upload to Glacier has a fixed overhead, which Glacier uses to track. It's our internal index. If the file is too small, then the index becomes a significant portion of your archive. So aggregating large number of small files helps in this case because you can lower the total cost of when you upload the data. On the other hand, you do not want the archive size to be too big. So this is in consideration of when you need to retrieve the data. At the moment, most of the Glacier retrievals are free. Every month, you get 5% of free retrieval tier that you can use spread over every day in a month. However, if you need to retrieve more than that amount of data, you will be billed based on how quickly you restore the data. So in this case, if you aggregate your objects to a very large archive size, the charges can go up when you retrieve it because you have to pull back the whole thing. So based on your business needs, there's typically an ideal archive size, and we've seen customers use ranges like 10 megabytes or hundreds of megabytes when they aggregate their small files. Next, I want to talk about uploading large files. This is the contrary to the previous slide. I have a few large files. I don't have a whole lot of small files. What's the best way to upload them? Uploading large files over the internet can be challenging because the longer you hold the connection open, the longer it is for the connection to be shut down, to be reset, and then you will have to restart your transmission, and it can be costly. So we recommend using a feature called multi-part upload with large archives. Typically, we've seen anything bigger than 100 megabytes is when we would recommend using multi-part upload. Using multi-part upload allows you to upload parts of the file in concurrent fashion. Thus, you can improve your upload throughput. When you do a multi-part upload, you will make 3 calls. To start, you do initiate multi-part upload and pass on a part size. To determine the part size, you can look at your current network bandwidth and throughput. And we typically recommend something like a few megabytes to 10 or 20 megabytes if your connection speed is not very stable. Once you make the first call, you get back an upload ID. This is the upload ID that you will use for the entire upload of all the parts. You iterate through your parts, use the upload ID, and then send portions of your large file up to Glacier. When you've gone through this process, then you will call complete multi-part upload, pass the upload ID, and this is when we get back an archive ID for you. An archive ID is a unique identifier generated by Glacier to track your archive. When you receive the archive ID, that means your upload has been done completely. The third best practice I want to highlight is how to optimize for data retrieval and download. As I mentioned earlier, retrieval and download are separate processes. Because Glacier is an archival system, there's a 2-step process to get your data out. The first step is to do a retrieval, which typically takes 4 hours. That is the process where Glacier prepares your archival data and makes them available for download. You can download the data into your on-premises applications, or you can pull the data into an EC2 instance that's co-located with the data center. In terms of retrieval, Glacier offers a capability called range retrieval. What is range retrieval? If you are retrieving a large object, you can retrieve parts of the object and reduce cost. For example, if I have a 4 gigabyte object that is a collection of log files, if there is a way for you to identify which one of the log files that you are looking for, and if there's a way to index into this file, then you can just retrieve that single file without having to retrieve the entire file. This can be big cost savings for you. Another creative way of using range retrieval is to speed up your retrieval throughput. Typically, we see customers retrieve a large object by spreading it out over many hours. Going back to the 4 gig file again, by default, if you do a single retrieval, it will be done over 4 hours. So your retrieval peak rate will be 1 gigabyte per hour. If you spread it out, you can lower this. But in certain cases, some customers need their data back as quickly as possible. So how do they do that? What they can do is initiate multiple range retrievals simultaneously. This allows you to get your data back sooner, especially when the data is very big. And you can start with small parts of the object to work with. In addition, there's a ranged download feature, or the ranged get capability. This is useful when you want to download parts of the data, or when you want to parallelize downloading a large archival once it's been retrieved. Do take note that at the moment, Glacier stages your retrieved data for 24 hours. So one of the best practices is to figure out that, hey, I have enough bandwidth to download data, to download the amount of data that I have retrieved within 24 hours. For customers who've uploaded lots of data but no longer have a fast internet connection, it might be challenging to pull down terabytes of data within 24 hours. So the best practice here would be, I only want to retrieve the amount of data that I can download in the 24-hour period. So I want to drill in a little bit into a range retrieval example. Take, for example, a 12 gigabyte archive. If we do the standard retrieval process, this takes 4 hours, then you'll be billed equivalent of a 3 gigabyte per hour peak retrieval rate. However, if you do this retrieval over 24 hours using 6 consecutive jobs, then your peak retrieval rate will be only 0.5 gigabyte per hour. As you can see, spreading retrievals over a longer period of time can save retrieval costs. So these are some of the best practices we just highlighted. Again, I want to remind you of some of the Amazon Glacier benefits so that you can build them into your application and take advantage of it when you are designing your archival solution. Amazon Glacier is a low-cost archival storage, starting at 1 cent gigabyte per month. We advise you to do a TCO analysis with your alternative options and compare with Amazon Glacier for 3-year, 5-year, or maybe a 10-year TCO comparison. Amazon Glacier is also very secure. We store your data in a very secure manner in that all of your data at rest is encrypted using server-side encryption by default. We've seen customers who are extra paranoid about their security, so they send us secure data. But for most of us, the server-side encryption is sufficient, which we guarantee that data at rest is secure. What does this mean? This means that nobody can walk away from the Amazon data center with a hard drive or a device of our choosing that has your data on it. The third benefit is Amazon Glacier is highly durable. It is designed with 11 nines of durability. As I mentioned, this means that if you store 10,000 archives, the chance of losing one is over 10 million years. Amazon Glacier is also very simple to use. You create a vault, and you can start archiving the data immediately. It's also very flexible because you don't have to pay for what you use. And last but not least, you can leverage all of the Amazon Web Services along with Amazon Glacier, such as EC2, RDS, and DynamoDB. So that covers most of the content we want to share with you in terms of best practices and the benefits of Amazon Glacier. I will now open up for questions.
So this is Colin Glacier. I'm joining the call. So the first question we have is, what is the cipher strength of the encryption? So we use AES 256 encryption throughout the actual service itself, both for data transfer, and then we use a similar strength of encryption at rest. The next question that I have is error detection part of the upload and download process? So yes, that's actually enforced. In the case of Glacier, it's actually a little bit different than S3, where due to the fact that they support browser-based upload and download, where you aren't necessarily going to be checking checksums on transfer and things like that, they allow you not to supply, for example, a checksum on upload. In our case, we actually enforce that. So you have to supply a SHA-256 tree hash, and there's some documentation there that explains exactly what that is. But essentially, it is a tree hash that's built out of 1 megabyte chunks that are SHA-256 checksummed and then combined in sort of an interesting fashion. What that is done, what happens there is then that's actually checked on our side in all cases, and we make sure that the bytes received are essentially the bytes sent, and that's enforced on both client and server side. And then we do the same thing when we're moving data around internally or when we're returning data to you for download. So that's enforced in all cases. The next question I have, pardon me, is how much data can be retrieved from Glacier and attached to an EC2/S3 server? It sounds like Glacier pulls data from tapes into a temp location and then moves it out. So there's no limitation on the amount of data that can be retrieved from Glacier, but I would sort of just clarify a little that it can actually be directly attached at that point, right? So the workflow is that when data is retrieved, it's pulled to a staging area. The staging area is just basically some more readily accessible storage that then a download can be initiated from. But the details of that are hidden from you as to what exactly the storage is really landing on. There was another question relating to that. And then that can just be downloaded. So however much data you have, you should be able to pull out within whatever time window you'd like and pull to EC2 or across the internet or wherever you'd like. The next question I have here is what is the relationship between an archive and a file? If an archive stores several files, let's say compressed, can just one of those files be downloaded with range retrieval? That actually can be very tricky. So yes, that can be done, but you have to very carefully actually sort of figure out what file format to use. So you can use file formats like zip or RAR or things like that. But in some of those cases, it's obviously going to move around and sort of chunk up the file into sort of indexed locations. So doing a range retrieval then becomes impossible. But there are some formats that actually do a good job of giving you contiguous files that are aggregated together into sort of a larger file. So there's a presentation I can send along after this that covers that in some detail that we did last year at reInvent. That talks about various file formats and how that can be done. It is accomplishable, but you have to essentially be careful.
So I'll take this one question. There's a question about what's the difference in direct connect upload bandwidth versus non-direct connect upload bandwidth. So we've actually seen several customers with large archival needs when they're designing the system. They actually think about uploads as well as exit, because they think about, hey, how much bandwidth do I need to be able to pull all of my data if it's a disaster recovery situation? So at the moment, Direct Connect, all the data that comes into Glacier using Direct Connect is free. And when you download data from Direct Connect, I think we offer multiple rates, but the lowest one is 2 cents per gigabyte out. Compared to non-Direct Connect download rates, which are, this is significantly lower. But then you pay for the Direct Connect connection fee. There are two options. One is the 1 gigabit per second. The other one is the 10 gigabit per second. I think the 10 gigabit per second is $2.25 per hour. So it's simply $54 per day, or $1,500 a month. So the other thing to note here is you want to make sure that Glacier Direct Connect is available in your area. And then typically, I think there is a contract. There's a minimum, length to sign up. It's not at the moment, it's not a, use it once and then just, unsubscribe model. So there's another question. Can you explain the 24-hour download process in a little bit more detail? What happens if the 24 hours is not enough to download archive? Do we lose it or is it still there? So let me just go back and share a little bit of why the 24 hours. So Glacier makes your data available for download after 4 hours. We put it on our staging area. So you're not charged for the fact that the data is there for you to download for 24 hours. If it's longer than 24 hours, your data does disappear because we have a staging area that's shared by all of our customers. So the advice here is assess your download speed. If you need to pull this out of from the internet to your on-premise, if you figure out a number, then you can say, hey, how much data can I download over the internet over 24 hours? And then I'll just make sure that I do not retrieve more than that amount in a 24-hour period. Now, so this is not a problem if you pull the data into an EC2 instance or any of the AWS services that's within the co-located data center. The network throughput there is typically a lot higher than what you can achieve using your downloads through the internet. So this limitation, this is really a consideration for downloading over the internet.
Okay, I'll take the next few questions here. So first question is, will there be a nicer user interface for customers? So I think what this is getting at is the console functionality for Glacier, which is a little bit more limited. You can do essentially vault-level operations, but you can't actually do archive-level operations. And the reason for that is essentially that we don't maintain a live index of your data for you. So generally speaking, that's some sort of client-side application that's maintaining that index of pointers into the actual archival data. So since we don't have a view into that, we really can't present something that would be sort of very user-friendly from the console, at least as is. So what we recommend there and what we sort of expect there is for folks to use other applications to get at us that maintain that index. So that there's a large number of tools out there that provide pretty interesting user interfaces, the sorts of things you'd be used to, like a file and a directory structure, or just to give you a sense of sort of some of the differences, some of our larger clients who are building customized applications might be hanging a great deal of metadata, say, relating to a video or media archive or something like that off of individual archives, and then being able to sort of search that. So sort of somewhat is application dependent, but if you're thinking just about sort of your traditional file and directory structure, there's quite a few tools that will do that for you. Another option for folks who don't necessarily want to go off and use one of those third-party tools would be to use S3 Glacier. So using the S3 console, you can actually list what the contents of your bucket is. You can see objects, dive into individual ones. So what you would do there is you just would upload the data to S3, arrange it and sort of name it as you'd like, and then transition those objects to Glacier using a lifecycle policy. So that'd be my recommended sort of simple plan for that.
Yeah, thank you, Colin. So I just want to add a little bit more, and this is also one of the customer questions. What's the difference between S3 Glacier storage type and Glacier itself? So Glacier is a separate service compared to S3, whereas S3 does support this Glacier storage class, which internally uses Glacier. So the main difference is S3 Glacier is used for bulk transfers. Typically, customers look at a bucket and say, hey, this is all of my images, all my log files from 3 months ago. I do not need to access them anymore. So they set a policy to archive them into Glacier. When they do this, all the Glacier prices apply to the S3 customer. So we look at S3 as just a client that's enabled on S3 to transfer data to Glacier. So what S3 Glacier does not support at the moment is single object archival. Right? This is a little bit of flexibility you lose for the trade-off of being able to have a hot index. You can list thousands of objects as if they're still in S3, where the storage is actually on Glacier and you're saving the cost for storage. However, you will not be able to say just copy this transition a single object into Glacier. You can only do that by using Glacier directly. So customers thinking about using Glacier, you have to compare the pros and cons of both services. But the highlight is one is for bulk operation, large number of objects. The Glacier itself is really for single object archival, and you have the flexibility there.
Okay. The next question I have is relating to IAM policies. So it says you mentioned IAM to allow upload but deny deletion of files. What's the best practice for this function? Presently, we've set our IAM policy for developers to deny, delete, archive. Are there other policies we should use for data protection? So that would be the primary one, right? If you wanted to get some sort of functionality where folks could upload but then not actually delete, we designed it so that that would be essentially what you would have to do. Again, just to highlight a difference here, unlike S3, you can't actually overwrite an archive, right? Because you're just supplying us a data stream and we're supplying you an identifier. So by design, you could never overwrite something with that same identifier. So delete archive will do most of what you need. There's another restriction that we have in place specifically, which is that you can't delete a vault if there are any archives in that vault. In fact, there's even a window where we haven't necessarily generated an inventory, where we, just for assurance that something could have been added later, we sort of hold off on allowing you to delete a vault. So you could also deny delete vault, but generally that protection is already built in for you if you actually have the delete archive rule denied. For completeness, I'd probably put that one in just in case you didn't have any archives in the vault, so that your application couldn't be sort of have a sort of a denial of service attack effectively on it. The other really important thing for IAM policies is to not give out the root account credentials, right? So you want to make sure that all of your applications and all of your users are using an IAM user other than an administrator. Otherwise, the actual account holder, right, the root account holder can go in and change any of the policies.
Yeah, so I want to take this question. If I want to download to a local EC2 instance, how do I verify that the EC2 instance is in the same data center? So this is actually quite straightforward. So Glacier is available in 6 AWS regions, 3 in the US, 1 in Europe, and as of today, 2 in Asia Pacific, including Sydney. So you just have to stand up an EC2 instance in the same data center that Glacier is located. So I see another question about upload, optimizing for upload. So question is, our campus has a 10 gig Internet 2 connection. Is there a way to ensure it gets used sending data to Glacier for maximum transfer speed? So I think a couple of things you can do. Obviously, do some testing and play around with the number of threads that you use to concurrently upload archives, as well as doing multi-part upload, the part size as well as the number of parts. I think typically, as I mentioned, 10 all the way up to like 100 megabytes are somewhere we see is the optimal sizing for parts. And in terms of thread, I think it really depends on your application. We've seen customers who had some bugs or some resource leak in the application, so that over time they see the throughput, the upload throughput drops. So if you see that, we would recommend checking for resource leaks, and then you can detect that by doing something equivalent of, if I see a resource leak, if I restart the application and the throughput goes back up, that means there's probably something in the application that needs to be optimized.
So a few quick questions, other ones. So if you have a vault with many archives, how do you delete multiple archives at one time? So we don't actually allow that functionality. There's no, S3 has this equivalent. They have a bulk delete functionality. But with the Glacier APIs, you have to do an individual deletion of an archive. If you actually have this sort of use case where you want to do mass deletions, in some sort of rolling window, and you don't want to do a large number of them, this would be another case where S3 Glacier may be more appropriate if it's an age-based deletion, right? So in that case, you could set up a lifecycle policy to transition the objects to Glacier, so it's in that storage class once you upload them to S3. And then after N days, after 90 days or 120 days or whatever you'd like, you could then have another policy that kicks in and actually deletes them for you.
Yeah. So I'll take this question for request pricing. Question is, suppose I have one request for 100 GB of data. Is the cost the same as 10 requests of 10 GB of data? So first to clarify, the pricing, let's say for one of our lowest region is 5 cents for every 1,000 operations. So if you upload an archive of 100 gigabytes, that's one request. It'll cost you, it will not cost you 5 cents. It'll cost you 5 cents divided by 1,000. If you upload it using 10 parts at 10 gigabytes each, then you'll be issuing 10 requests. So the total request charges will be 10x as if it's one request. So just also want to highlight that if you use multi-part, every single part upload that you do for the multi-part counts as one request. So it does affect your cost for uploading data a little bit.
Okay, I got a couple more questions here. So the first question, the next question I see is because of how Glacier is designed with a 3 to 5 hour retrieval window, would you say it's more secure from a data breach compared to S3? So I don't really think that I would call that as a difference. They're both designed to be highly secure. So from an internal standpoint, the amount of security locking down either of those services is both, in both cases fairly intense. If you're thinking about a data breach in terms of accidental access or malicious access by someone on your side, more time is better than less time. But then, after that 3 to 5 hours, you could, if somebody had credentials they shouldn't have, they'd be able to get at data as quickly as they would from S3. There are a few things that, again, I wouldn't want to imply in any way, shape, or form here that S3 is less secure. But just from a sort of a use case difference, one thing that Glacier doesn't offer is shared object access, right? So that can be a benefit just from a user administrator, accident avoidance standpoint. So you can't, as an administrator, accidentally share your data with another account, for instance, or accidentally make it public, right? It's completely limited to the account holder and any IAM users, obviously, in that account.
So there's a question for when I use lifecycle policy and the storage type changes to Glacier. However, when I go to the Glacier page, I do not see any archives. What's happening? So this is the expected behavior. As I mentioned, the Glacier storage class for S3 is part of S3. So you do not get direct access to Glacier. Like S3 internally transfers the data to some Glacier vaults, but S3 manages all of the Glacier storage and the vaults for you. And you will not be able to interact with these vaults directly. You can interact with S3, and then you'll be able to look up whether an object is on Glacier storage class or in standard or RS. So this is completely expected behavior.
Next question I see is, are there any time limits to the multi-part uploads? Can a single archive upload span multiple days where uploading only happens during certain times? So this is a little bit tricky. You can't just initiate a multi-part upload and then upload a part and then wait a number of days and then upload the next part, anything like that, where you'd be sort of trying to use it as an incremental backup on a daily basis and then after some great length of time complete your multi-part upload. So the time limits there are designed to make sure we're not punishing normal use cases. So as long as we're seeing a relatively steady stream of uploaded parts for a given upload ID, that upload won't expire. And we do see cases where, because of the size of the pipes to us, or because of the size of an archive, that a multi-part upload can take multiple days. But generally speaking, we'd see a fairly steady stream of parts for that, and the part size chosen would be such that we'd be able to see that there is ongoing activity for that upload, and then not actually have that upload expire.
So there's a good question here. Can you give me an example of how to set up photo or video archive? Would groups of content files be placed into a single archive by time or subject? Is the unit of restore the best guidance for when to use a separate archive? They're a great question. So I'll share with you like one of our customers who is a provider of they provide a service where you send them like photos and home videos, and they digitize everything and then enable like sharing, and then they will produce DVDs for you. So what this company figured out is, hey, all the objects that customers send us, like videos and images, right? They typically make a DVD out of that after within the first 3 to 4 months. So they decided to archive everything older than 4 months into Glacier. So we talked to them. They said, hey, we have so much content that and the average object size is also fairly large. They're like in close to megabytes, or like the high hundreds of kilobytes. They actually did not do any aggregation. And then this allows them to pull out single objects when they needed, and not have to worry about using range retrieval and all that stuff. So I think for your specific use case, you should think about how much content am I uploading? Is this a ongoing process? And is there a big difference in like the smallest to the largest files? Obviously, aggregation will save you on number of total requests, but it also may be challenging to figure out what's the best way to archive if you do not know about your access patterns. Then in terms of grouping, I think by customer ID by subject is a pretty good way to do that. You can also do by time. This is like the data warehouse sliding window. You can also do a combination of time and customer ID if you believe that a customer only generates so much content within a certain time frame. So this is like a composite key in data partitioning. So all of those are applicable options. I think the thing is you have to know what is the access pattern and what is the data generation pattern. These are the two key things to sort out before you design the application. So hope that helps.
Okay. The next question I have here is, short of a dedicated high bandwidth internet connection, what are some other strategies for uploading large, many terabyte set of data? Can we send hard drives? Are there partner sites with high bandwidth connections? So I think Henry touched a little bit about this in the presentation, but just to reiterate, so yeah, we see essentially three ways to get data to us. One is just using the normal internet. You ought to be able to do that in most cases for most connections, unless you have just an incredibly massive data set, pretty successfully. And I would just use the recommendations that he already took you through in terms of choosing a part size that's sort of moderate number of megabytes generally is a good idea. Not too small, not too large. If you can't do that, like for example, if you have a very large sort of data set as a one-time event, or maybe a couple-time events, import-export can be suitable. That's where you can actually send us physical media, and we'll import that. But again, that's generally less cost-effective than just using your existing bandwidth, especially if you can do that over a reasonable time period. And then partner sites with high bandwidth connections, or any sort of direct peering is sort of where I take that. You can use direct connect, and that's generally really cost-effective if you have large amounts of data on an ongoing basis that'll be going to or from us.
Yeah, I just want to add a little bit to Colin's comment there. So you are able to use import-export for Glacier. At the moment, we import your disk image as a single archive. So this is suitable for customers who plan to rehydrate the disk into an EC2 instance, and then use that entire partition with some EC2 application. But it is not particularly suitable if you want to import single objects. So we have had customers who send us a drive then realize, hey, I actually want to be able to store individual files on the drive as archives. What do they do? So there is an alternative. So you can create an import job through S3 where we will import your objects, and then you can import into a bucket on S3 that has this lifecycle policy. So you go through S3, then archive into Glacier. That's an indirect way of using import-export to archive objects from hard drives.
Okay. Next question I have here is just a quick one. Once a retrieval request has been placed, can it be canceled mid-job? No, essentially. So basically, the moment that a request is taken for a retrieval job, we carry through that to completion, and it can't be canceled at this time. Next question I have is, when transferring files to your vault, is there a secure tunnel enforced when transferring to prevent capturing files before it hits your servers? So we don't actually enforce that. This is by customer demand, essentially. We allow both HTTP and HTTPS transfers. And the problem there is for a lot of use cases, essentially, HTTPS doesn't give sufficient throughput for folks. Now, you wouldn't obviously want to transfer completely unencrypted files. Security is a big concern for you there. So what we recommend is use HTTPS unless you absolutely can't. And then we always recommend people actually enforce some form of encryption on the client side before sending things to us. It's the safest thing that you can do. Even though we do server-side encryption at rest for all archives in all cases on Glacier, there's no reason why you wouldn't want to just encrypt on your side as well, just for that extra sort of margin of safety, if that is a concern for you. It also would allow you then to, of course, have secure, if somebody were to capture the bits on the wire or anything like that, they wouldn't be able to get at them.
Yeah, so I think Colin already answered this question. So some of the files that are uploaded to S3 were through lifecycle. they were not still encrypted when they were uploaded to S3. Can I enable this encryption now that these files are on Glacier? So as Colin mentioned, everything that's stored in Glacier is automatically encrypted using server-side encryption. So even if your object in S3 is not did not use server-side encryption, when it transfers to Glacier, it's encrypted. And as I highlighted earlier, this is a move. This is not a copy operation. Another question here is, state of Massachusetts law requires that any data leaving the premise electronically must be encrypted if there's personal information contained within them. What's the way to create the encrypted link? Do I need to use a local encryption solution? I think the best recommendation here is to send us encrypted data, and then you will always get the data that's encrypted based on your business needs. And if you need to comply and do some auditing, you can always say, hey, this is the encryption method that I use. The data in Glacier is already server-side encrypted, so it's like double encrypted, and when I get it out, it's still encrypted. And as the compliance regulations change, you can modify your encryption requirements before you send the data to Glacier. Obviously, we will always be pursuing some of the strongest encryption, server-side encryption on Glacier, but it is better for you to go through the audit knowing what client-side encryption you used.
Next question I have is the staging area encrypted as well? And the answer is yes. So the basic rule with us is that all data at rest is encrypted at all times, whenever at rest, wherever at rest. So basically in every case the answer will be yes. Next question I have is, sorry here, just a sec. Next question I have is, can you retrieve Glacier content through the management console? So I touched on that a little bit at the top of this Q&A session. So no, you can't actually access any of the content through the management console for anything uploaded to Glacier directly, but you can for anything for S3 Glacier, essentially, you can get at that data. Okay, so I have this is a quick question. What's the maximum size the part size I can use for a very large archival? So we support up to 4 gigabytes per part. But for the archive, the limit is 40 terabytes per archive. So 4 GB is your maximum limit. And typically we see people use less than that. Like if you can sustain 4 GB upload without like a connection issue or like internet activity, I think you have very, very good connectivity there. Next question I have is it a requirement to upload archives in a zip or similar compression format? There is no requirement around that at all. So essentially the data that you send to us is uninterpreted. We don't look at the type. We don't look at really anything to do with it. We don't understand it other than it just being a contiguous set of bits. So you're welcome to send it in whatever format you like. We don't preserve the MIME type, just to let you know that. And in terms of advantages, disadvantages there, obviously doing some compression on your side, most of the time that people are trying to do archival, they're trying to do it for cost reasons, and that can be a huge driver of cost. So it is worth, for many use cases, actually going ahead and doing that compression, unless you have something that is, some data that is not terribly compressible, like some image data or some video data is very poor compressibility.
Yeah. So the question is there a way to set up a routine monthly storage usage report? I'm not sure how automated you want this to be, but we do provide an inventory, and in the console you can see the size of the vault with a 24-hour delay. So if you want to do more auditing on the archives you can always retrieve a vault inventory every month, and then you can look at what's the size, how many archives in a vault, and we'll also have a timestamp on when the vault is generated. So if you are okay with a 24-hour delay, then I think for the monthly report, retrieving a vault is probably the best solution.
Next question I have relates to how do you update an archive with an appended file, and basically calling out some difficulty that they had with this. So there is no way, per what I said earlier, to actually update an archive. And this is sort of considered to be a feature, not a bug. So it isn't a feature we'd be adding in future. The idea here is that once you send us that data, we guarantee that data will stay intact and unchanged no matter what. So it can only ever be created or deleted by design. So the thing to do here would be to pull back that data, pull back the data you're essentially wishing to append to, or if you have another copy of that, use that local copy, append what you need to append, create a new archive with the larger version, and then delete your old archive. And that's really the only way to do sort of an in situ update. And then you'd obviously change your index, your local index, to point at the new archive that you've just created.
Okay, so question is, when will AWS support archive movement via import-export service? I think we touched on using import service to move large amounts of data to Glacier. So I want to talk about export for the moment. So as of now, S3 export is supported. So there's no direct support for exporting Glacier archives from Glacier directly. However, if you are using S3 lifecycle to Glacier, what you can do is initiate a few restore jobs from Glacier so that your objects are restored. And when they're restored, you can set a timestamp basically of a retention period. Let's say keep these objects in S3 as in directly available for, let's say, 5 days. And then you can initiate an export job for these objects, and then you can export them through S3. And then once you're done, these objects will just automatically expire, and the copy will be gone, and you will no longer be charged. So this is the additional step that you have to go through when you are exporting objects from Glacier that has been archived through S3.
Next question I have is there a downside to uploading through S3 archival rules? So I don't think there's a downside per se. The one way to think about it is if you're an existing S3 customer, or if you want S3-like semantics to get at your data, right? So again, sort of a simple listing, name value pair type structure to access and find data, then S3 can be totally appropriate and is a nice fit, right? There's a lot of existing tools that work against S3, and that would be, there'd be no sort of downside to essentially doing that. The things that Glacier Direct gets you, over and above that is maybe a little bit more control over how to get data to us, right? So, enforcing the checksum on the tree hash, allowing you to do sort of ranged retrievals when you're pulling back data, allowing you to get SNS notifications when the jobs are complete. There are a couple little differences like that, which may or may not be valid for a use case, but generally speaking, for sort of, a casual use case or sort of generic use case, S3 Glacier is totally appropriate.
Yeah. I just want to add to that, as earlier we talked about, one of the best practices is to optimize cost and aggregate objects. So we have seen customers with lots and lots of small S3 objects. They want to leverage Glacier, but then the thing to understand here is every object that's transitioned, transitioned to Glacier on its own incurs one request, right? So, some of them see like a high bill because they have billions of objects transitioned to Glacier. So there are a couple of ways they can do this. One is some customers stand up an EC2 instance. They pull, let's say, 50,000 small objects, group them together, and then send it to Glacier. So they've had quite a bit of success with that. So I think the key thing here is, when you try using S3 lifecycle to Glacier, just take a look at your average object size, do some cost analysis before you do that. And we actually have a very good, a page on our doc site to walk you through some of the considerations. So we'll follow up and send you that so you can review before you use S3 archive.
Next question I have is, I heard that we don't pay for the data transfer costs when putting data into Glacier. We only pay per gig per month and retrieval fees. Is that always true that sending data in does not incur data transfer costs? So I just want to add this one because Henry kind of touched on this. So there is a request cost of 5 cents per thousand in the lowest cost region. It's a little bit higher in some of the other regions. So that is something to consider when transferring sort of extremely large numbers of files in that can add up. But your actual data transfer cost so data transit, is free. And then so over and above that, you really are only paying the per gig per month cost and then any retrieval and request costs ahead of that. The other one to factor in there is deletion cost, of course. So if you're deleting before 90 days, then there's an additional cost there as well. So again, the service being designed for long-term storage, really the most suitable use cases are extremely long-lived data.
So there's a question on, is there a best practice to do large downloads to an EC2 instance in the co-located region from Glacier instead of over the raw internet? So I think the same considerations apply. You always want to maximize your throughput by having more threads, by using the range get or range download capability so that you can pull back the data as quickly as you can. We haven't really heard any issues from pulling it into a co-located EC2 instance because the network bandwidth is just so much better and more stable over the internet. So I would say, if you run into a problem, optimize. Otherwise, don't worry about it.
Okay. Next question I have is, in the case of a multi-part concurrent upload, how does one specify the order of parts in an archive? So essentially what that API looks like is that you initiate the upload with a size, and then you have to give us, every single part has to be that size except for the last part, which has to be smaller than or equal to that size. And when you actually upload an individual part, you specify an absolute byte range. So just to give a quick example, so let's say that you were uploading a 17 megabyte archive, and you chose a 4 megabyte part size. One of your uploads would be from 0 to 4 megabytes. One of your other uploads might be from 8 to 12 megabytes, and those could happen concurrently. Once all the parts and all the range is uploaded, you then do that complete call. We then make sure that we have all the contiguous 17 bytes that have been uploaded across whatever the part size you have, and we compute the checksum on our side, make sure it matches the one that you sent us for the complete call, and then successfully store the archive provided that everything matches.
So there's a question. I generate a daily database backup that is about 2 gigabytes and want to archive my daily backups to Glacier. I end up with a single large zip file. How exactly do I initiate transfer of this file? Where's the documentation of the SDK sample? So I think so you can basically reference our multi-part upload APIs and samples in our documentation. I think we'll follow up and send you a link on that. It's pretty straightforward. It's just you initiate the multi-part upload, get an upload ID, then you pick up a chunk size for your for the 2 gig file. That's something you have to experiment a little bit, and then you send all of the chunks using the upload ID, and then you close the upload with, and you get an archive ID. So I think that's pretty straightforward. Nothing specific to the backup. I want to just highlight. Typically, daily backups don't live on Glacier for very long. So we have actually had backup appliance vendors that are working with us. Customers rotate their backups as in they delete their daily backups within a week, right? So as I mentioned, Glacier is a long-term archival solution. If your data is deleted within 90 days, you'll be charged a early delete fee, right? So I just want to call that out and ensure that you assess the amount of deletes that you do with your backups, and then consider that as part of your TCO.
Next question I have is there a way to transfer files into Glacier without writing our own program or using Direct Connect? And yes, there absolutely are. There's a lot of third-party applications if you search around there, either on our forums or on some of our marketing pages that explain some of the clients that are out there. Another way, of course, is to just use S3. I mentioned that a few times. So there's even more clients for S3. So if you're looking for a simple directory structure, you can use one of them and then set a transition rule to make a lifecycle transition to Glacier for your content. Next question I have is, why use Glacier directly versus using the S3 Glacier lifecycle policy? So I think we covered that one a little bit earlier. I think that's a repeat. We also covered, does each upload count separately for pricing reasons, each a part upload, and the answer to that was yes. Are there applications that automate data direct upload to Glacier? So I think that's an interesting one to cover again from a client standpoint. So there are a number of tools that have sort of different patterns of upload to Glacier. So the two most common ones that we see are sort of an ad hoc usage application, where you're going in, you're doing specific directed operations on your vault, uploading, deleting, what have you. But actually, one of the really common patterns that we see are applications that are doing those automatic downloads and uploads, so specifically uploads. So these are things where they're sending a differential backup on a daily basis, or just backing up any file as you're updating it, any directory as you're updating it. So again, I'd search around for Glacier clients, and you'll find quite a few. It depends on your operating system and what sort of features you're looking at as to what would be appropriate there. So I wouldn't want to call out any specific third-party vendor there.
Yeah, I think just want to touch base on third-party vendors. So there are third-party applications, software you can install on Linux and Mac and Windows that's suitable for mostly like the consumer, prosumer grade. We also have a bunch of partners that we're integrating for backup appliances, for our NAS devices, for network transfer acceleration devices. So they're all doing that. So I think if you evaluate an option for your business, definitely look at doing it yourself as well as looking at some of the appliance vendors that's integrating with Glacier, and pick one that's suitable for you.
Okay. So I think that's all the time we have for questions today. So if your question wasn't answered, we'll be following up with you via email where possible to make sure that we get your question answered over the course of the next 2 days.
Okay. I'd like to extend a special thank you to Henry and Colin